A single file name can hijack a Linux machine when a careless shell script reads it the wrong way. Picture this. You download a tiny archive from an innocent-looking email, and nothing in the files is malicious. Yet your system gets compromised later. The trick? Malicious logic hidden in the file name of an entry inside the archive. That name just sits there until a sloppy shell workflow bumps into it and treats pieces like code. No macros, no double-clicking an exe, just a booby-trapped name waiting for unsafe parsing. In this video, we'll unpack how the attack works, why tools miss it, and the practical defenses you can roll out today. A recent campaign used a low-key lure, a short survey about beauty products with a small reward plus a harmless-looking archive attachment. Nothing screamed urgency, and there was no push to open it. Perfectly forgettable, perfectly plausible. Inside, one file carried a carefully crafted name, stuffed with characters Bash understands as special. Nothing triggers on extraction alone. But later, if an admin script, automation job, or helper tool handles that name without strict quoting, the shell can reinterpret pieces as instructions, kick off a download, and quietly stage a backdoor. Why does this work? Linux shells are powerful interpreters. In Bash, certain symbols aren't just characters. They change how commands run. If a script passes a file name through the shell without defensive quoting or uses risky constructs like dynamic evaluation and command substitution, that string stops being data and becomes directions. Attackers exploit three truths. File names can contain almost any character. Many scripts assume names are safe, and the shell obeys metacharacters when given the chance. One casual utility script is all it takes for a malicious name to spring to life. Once the shell misreads the name, the embedded logic typically decodes a tiny downloader, figures out the system's CPU architecture, and fetches a matching Linux binary. That binary phones home to a command and control service, retrieves an encrypted payload, and runs it straight from memory. In-memory execution is a big advantage for attackers. No obvious files to scan, minimal artifacts, and fast turnover. Researchers observed this chain delivering vShell, a Go-based backdoor with remote shell, file operations, tunneling, and encrypted communications, portable enough for servers, laptops, and even embedded devices. Here's why many antivirus tools missed it. Scanners excel at inspecting content, documents, scripts, and executables. File names, however, are usually treated as inert labels. This technique hides in that blind spot. The content can look clean because the danger lives in the metadata. Nothing executes until some later workflow reinterprets the name, and when the payload finally runs, it often stays in memory, skipping the disk footprint that many engines monitor. The result is a perfect storm. No obvious signals at rest, and very little residue after the fact. You might ask, who would ever feed a file name back into the shell? In practice, lots of quick and dirty automations do. Examples include helper scripts that reshape names with substitutions, pipelines that use unquoted expansions, or loops that parse command output instead of using safe, delimiter-aware methods. Even well-meaning cleanup jobs can stumble if they assume file names are tame. The safer mental model is simple. Treat every file name like untrusted user input. If you wouldn't allow special characters from a web form, don't let them slip through your shell scripts either. Defend early by shrinking exposure. At the email gateway, quarantine or sandbox archives from untrusted senders, and consider special handling for RAR and multi-part archives. Use content disarm and reconstruct where possible. Add file name aware checks before extraction. Slag entries containing dangerous metacharacters, control characters, or odd Unicode your business doesn't need. If you process archives automatically, run that workflow in a sandbox with minimal privileges. Subtle signals help too. Flag messages that include archives, but never mention them in the body. This campaign leaned on that quiet, forgettable style. Next, fix the root cause in code. In shell scripts, always quote expansions. Avoid dynamic evaluation and use null delimited processing for file names. Never parse the output of generic listing commands. Use robust primitives or higher-level libraries instead. Add a linter like shellcheck to CI to catch unsafe patterns before they ship. Then harden the runtime. Mount temporary directories with no exec where feasible. Confine archive handlers and mail clients with AppArmor or SE Linux. and sandbox any pipeline that touches untrusted archives using lightweight container or namespace tools. Boost visibility with targeted telemetry. Alert on short-lived shells that immediately decode data and spawn network activity. Capture command line arguments for process starts and correlate them with recent archive operations on the same host. Hunt for unusual file names, those with code-like symbols, in locations where you ingest user content. Map detections to MITRE ATT&CK to guide hunts and triage. Don't forget people and vendors. Brief users to be cautious with unsolicited archives, train admins on quoting pitfalls, and ask your EDR provider about file name scanning and in-memory telemetry. There's a parallel trend after initial access, staying stealthy by avoiding the usual system call hooks. Tools like RingReaper lean on Linux's I/O Uring, a high-performance I/O interface that can sidestep what many EDRs traditionally watch. The takeaway for defenders: extend observability to include I/O Uring activity or augment with kernel-level eBPF telemetry. Combine that with file name-aware controls, safer scripting, and sandboxed handling of archives, and you'll close both the front door and the back hallways attackers are using. Tight basics beat flashy hacks, consistently. If this helped, please like the video, subscribe for more practical security breakdowns, and drop a comment with the shell safety habit or detection you're adopting next.